Alrighty, welcome to Module 6, Lesson 26, Volume of Composite Three-Dimensional Objects. Okay, again, a bit of a repeat or an extension of what we did way back when in Module 3. Okay, well, let's get right to it. Alright, so here we go. Example 1, find the volume of the three-dimensional object composed of two right rectangular prisms. Okay, I think this is something you can do, so I'm going to pause right here and have you give it a whirl. Okay, so let's take a look at what we did here. Again, we're going ahead and find the volume of this three-dimensional object. All right, so what I want to do therefore is I want to get the volume of both the top prism and the bottom prism, because they together, that sum, will give me the volume of the object. Okay, so we have to kind of decomposing in a sense here. Nothing to worry about. Nothing. We don't need to worry about the blocking of any surface area here, because we're not dealing with that. We're dealing with volume, the amount of space these two things take up. Okay, so step number 1, let's go ahead and calculate the volume of that top prism. Okay, and here are the values that we need. All right, so we have 4 times 5 times 5 meters cubed. Okay, and that, of course, is, not of course, but 100 meters cubed for that top prism. Let's get the volume of the bottom prism. And here we go, we have our 3 there. And then we have 10 meters that way, because that's that 5 plus the other 5 here. So we have 5 there and then 5 here. Okay, so that's giving us our 10 meters across there. And then we have 6 and 4. Okay, we got 4 there and 6 there going that way. And therefore we have 10 again. So we have 3 by 10 by 10 meters cubed, 300 meters cubed for the bottom prism. And altogether our total volume is 400 cubic meters. Okie doke. Let's move on here. We are going to now find the volume of the following three-dimensional figure, composed again of two right rectangular prisms. Okay, so just like the other, same situation, just kind of different setup. Okay, so go ahead and figure this one out and come on back. Okay, so let's go ahead and compare answers here. Alright, so again, the volume of the entire object is the volume of these two prisms. The one I'm calling back prism and the other front prism. Okay, so let's go ahead and work on the back prism. And there are the figures, or the values that I need, the dimensions that I need to apply. 10 times 2 times 9 inches cubed. There we go, 180 cubic inches for that back prism. Volume of the front prism. There are my values, and plug those in. 6 times 2 times 9 inches cubed, 108 cubic inches. The total volume, 280 cubic inches. Okay, so those two were pretty breezy, easy. Okay, now this one here, they want us to, the right trapezoidal prism is composed of a right rectangular prism joined with a right triangular prism. Okay, this one's a little bit more entailed, because it's asking us to find the volume of the right trapezoidal prism, shown in the diagram by using two different strategies. If you want to go ahead and do it on your own, go right ahead right away. Just pause right now, and you may know your two different strategies already. If not, you can hang on here, because I'll give you the two strategies I think apply. Alright, so I'll give you a chance to pause right now. Okay, well, you've stayed, you've remained, and here we go. Okay, so strategy number 1 would be to decompose into a right rectangular prism and a right triangular prism. Okay, and you can see that right here. Here's our right rectangular prism right there. All right, and then we have a right triangular prism right over here. Okay, so you can go ahead. Strategy number one would be to go ahead and decompose and find each of those separately. Okay, but if you don't want to do that, you could also use strategy number two, which would be to use the trapezoidal prism. Use the entire prism. Use the formula for getting the area, of course, of a trapezoid, because we're going to need that for our base. Okay. All right, I made a mess of that one. But anyway, go ahead now and use one of these strategies or both of these strategies, and then come on back and you can check in and see what I did. Okay, let's go ahead and take a look at, let's use strategy number one. Okay, we're going to decompose into a right rectangular prism. So the right rectangular prism right there, those are the two dimensions we need. So 2 times 3, okay, is going to give me the area of my base, okay. And now I need to apply the height, which is 1.5 centimeters. Therefore, I get 6 centimeters squared times 1.5 centimeters is 9 centimeters cubed. And let's keep remembering this. See, if I multiply a square number by just a regular old number, I'm going to end up with a cubed number. Okay, so just remember that into the future. I know we talked about it before, but wasn't quite sure if you knew that. Now we have that. We have 9 centimeters cubed for my the right rectangular prism. Okay, let's go ahead and look at the right triangular prism. Okay, and that's what we're going to find out right here. We need to get the base first. These are the numbers I need for the base, or the dimensions, and of course that's 1/2 base times height, and this is what I get. Okay, I got 3 3/8, and that would be 3 3/8. Actually, I didn't complete that. It should be centimeters squared. Okay. All right, and that's that right there. Oh, I did do it already. Look at I did do centimeters squared there. Okay, so that is the base right there, and of course I need to apply my height. Okay, which is 1.5 centimeters high, and to multiply that, and if I do, I get 5 1/16 centimeter cubed. Okay, that is the volume of that right triangular prism. And if I take both of those, the right rectangular prism and right triangular prism, add those together, I end up with 14 1/16 cubic centimeters for the volume. Okay, and that is strategy number one, using decomposition. Okay. All right, erase all that. Let's go ahead and look at strategy number two. Strategy number two says here the area of a trapezoid, if you remember, is 1/2, and then a plus b. And remember, this is a. Sorry, this is a here, and then this is b here. Okay, remember we have the base. There's two different bases. We've been calling those. Okay. All right, and so there we go. And so we have those two are, one is the 2 centimeters, we can see right here. The other's a little trickier because we've got to put that together. Okay, so we have 1/2, 4 1/4 plus 2. Okay, and here's how we get our 4 1/4 is we have our 2 here. Okay, that's that bit, and then we have 2 1/4 over there, and that's 4 1/4. That's what that is. We're going to add those two together because that's what the formula tells us. And then we're going to multiply, of course, by the height of the trapezoid. Okay, and the height is going to be that way. And that's 3 centimeters, as you can see. We've taken that from right there. Okay, 3 centimeters. We multiply those together. We end up with 9 3/8 centimeter squared. Okay, centimeters squared. So that is our area. Okay, the area of our base, that's that right there, 9 3/8 centimeters squared. Apply our height. Again, we get our base area, and then we multiply it by the height. Remember, we're talking about right prisms. And if we do that times 1.5, guess what we end up with? 14 1/16 cubic centimeters. Okay, which is the exact same answer as we came to using the strategy number 1 with the decomposing. Okay, so whichever one you like. I mean, if you get used to, I would say this right, using the trapezoid, if you get used to the whole trapezoid formula right here, okay, the area of a trapezoid formula, if you get used to that and you know that well, probably the best way to do it. No need to decompose. Yeah, probably be a little bit quicker. Okay, so here we are. Next here we have, we are going to find the volume of the right prism shown in the diagram, whose base is the region between the two right triangles. Okay, the two right triangles. Now, here are the right triangles are right here. Okay, so you can see here's our one right triangle there, another right triangle there. Okay, all right, so and we'll take a look at this now. It says right here, and you probably see in your book, it said to use 2 strategies, but I don't want to. Okay, I want to just use 1 strategy. All right. If you want to go ahead, give this a whirl. Remember, that's a hole right there. Okay, that's a hole going through. You can go right ahead and do it. Pause. If not, just stick around. I'll give you a moment to pause here. But if you want to, just stick around and we can do this one together. Okay, you're still here. Let's go ahead and do this together. All right. So the volume of this object is going to be the volume of that larger prism minus the volume of the smaller prism. Okay, and the larger prism is the whole part, is the solid part, and then the smaller prism is the hole that's been that's been taken out of it. Okay, that's been drilled out of it or whatever. Okay, and again, that is a hole right there. Okay, that's a hole. There's nothing. There's no volume in that hole. Okay. All right. So let's go ahead and do that. The volume of the larger prism. Okay. Again, is 1/2. This is a base is 3 right there because we said that is the base because we can see that's a right triangle. So therefore, that's going to be the base times the height. Okay. So that's going to give us that right there. That whole thing there. 1/2 of base times height. Times 4.5, of course, which is the length. Well, in this case, the length or the height, or the height, we would say, of this prism. Okay, and that's going to equal 27 cubic centimeters. Okay, 27 cubic centimeters. So that entire solid piece, ignoring the hole or the missing piece, is 27 cubic centimeters. Okay. All right, so now we're going to go ahead and find that smaller prism, which is actually a negative prism because it's the absence of matter. Okay, and that is going to be 1/2. We have our base and height, 1 1/2 times 2, and again times 4.5 because that is the entire height of the entire prism. Okay, and that is going to give us 6 3/4 cubic centimeters. Okay, so now to find out, to go back to our volume of the object, is the volume of that larger prism minus the volume of the smaller prism. So if we go ahead and do that, we end up with a net result of 20 1/4 cubic centimeters as the volume of that object. Okay. And again, if there's any issues with this and you had trouble following along, you can, of course, watch it again. But also give me a call. We don't have many days to. Well, you can send me an email. That'd be the best. And I'll always be checking my email throughout the summer. And if you do have some issues, please don't hesitate. Okay, so here we go. Okay, so here we go. We have example 3 sets up a situation here. We have a box with a length of 2 feet, width of 1.5 feet, and a height of 1.25 feet. And it contains fragile electronic equipment that is packed inside a larger box with 3 inches of styrofoam cushioning material on each side. Okay, and this cushioning material is above, below, left side, right side, front, and back. Okay, so you imagine now we got a box inside of a box which is cushioned with styrofoam cushioning material on all sides. All right, so that's the situation. Now this example, this problem is going to take us through 4 steps, A, B, C, and D, and take them one at a time. All right. The first one asks for the dimensions of the larger box. Okay, dimension of the larger box sounds like it might be easy, but it's not necessarily that easy, because you have to now take into consideration this 3 inches of styrofoam that's cushioning this smaller box. Okay, so these are the smaller box right here. Okay, here are the smaller box dimensions. So what I want you to try, give it a try, struggle a little bit if you need to, is to use those dimensions, the smaller box dimensions, and and consider the 3 inches of styrofoam that cushions it all around. Okay, and then see if you can come up with the dimensions of the larger box. All right, may take a little work, not something you do every day. So yeah, give it a try, come back, and we'll go over it together. Okay, so let's see where we are. All right, so the dimensions of the larger box. All right, 3 inches. We're thinking 3 inches all around. Okay. First thing to do, and I would suggest this very much so, is to convert that 3 inches to feet, because everything, all of the dimensions are given in feet. So let's go ahead and convert 3 inches to feet, and hopefully you did that. If you didn't, and this is helping you a bit, just go ahead and do it now. All right, so we have length. All right, so the length of the box, okay, we are going to have length of this larger box is the 2 feet, which is the smaller box, and then we have 1/4 of a foot, okay, which is the conversion of 3 inches, okay, and then another 1/4 of a foot, which is another conversion of 3 inches, okay. So we have the length, so we have to add 3 inches on each side, okay, to make room for that styrofoam sheet, okay. So now we're going to have a length of 2.5 feet for the larger box, okay. Now the width is that width of that smaller box, okay, and now I'm actually, what I decided to do is just go to decimals all over, okay. The width is 1.5. Now I have 0.25 feet on both sides, okay, to accommodate that styrofoam. And then now I have 2 feet and I changed all of those there, okay. And I have 2 feet for the width, okay. So here's the height. Height starts off with the 1.25, which is the smaller box. Again, adding 0.25 feet or 1/4 of a foot on each side, and I get 1.75 feet. Okay, so there are my dimensions of the the larger box. Okay, and these are going to be important. Okay, we're going to need these as well as the smaller box eventually. Okay, the next question B here, next part B, says. Design styrofoam right rectangular prisms that could be placed around the box to provide the cushioning. Okay, so you're going to give the dimensions and how many of each size are needed. Okay, give the dimensions and how many of each size are needed. All right, so you're going to imagine you have this box, this large box, small box in between. You've got to design these styrofoam sheets that are going to help cushion that smaller box. All right. So, well, I'm just going to go ahead. I'll give you a little moment to pause if you want to try it yourself. If not, just stick around. Again, doing this together is good because you'll invariably have to do it on your problem sets. Okay. So let's go ahead and do this together now. All right, so I went ahead and made a box, okay, Not a really great to scale box, not even a great three-dimensional representation of a box, but it's a box nonetheless, and it will give me something to work with. If you want to, right now, as I'm going along, go ahead and make yourself a box as well, okay? All right, so first thing I'm going to do is that I need a piece of styrofoam cushioning on that side. So I'm going to work on that side and the other side at the same time, okay? The side opposite of it. This will be this side right here as well, okay? So I'm going to need two, all right? And I'm going to need two sheets that are 1.75 feet times 2 feet times 0.25 feet, okay? So what these numbers are, of course, this 0.25 here is the thickness of the styrofoam sheet, which is also known as 3 inches, okay? All right, the 0.25. Now the 1.75, as you can see, and the 2 feet come from here. So you have 1.75 and 2, okay? So my base times my height, and then times my width, which is the 0.25, okay? All right, and then so I'm going to have another one on this side as well here, okay? So I have 2 of those. I'm going to need 2 of those, all right? This is the way I'm doing it, okay? Now you can, you may have done this, paused and did it yourself, and you may have come up with a different way, all right? So I noticed in the book they did come up with a different way, but this is how I decided to do it. So I have 2 of those, okay? Now what's happened is that this used to be 2.5 feet. See right over here. See 2.5 feet. But now that is only 2 feet because I have to pay attention to the 3 inches I took off here and here. Okay. All right. So I have. Let me get rid of this big purple arrow there. Okay. Yeah. So now I have 2 feet. So now I need 2 more pieces that are going to fit on the top and the bottom that are 2 feet, okay, that red line right there, 2 feet by 2 feet by 0.25, okay, 0.25, all right? So we got 2 by 2 by 0.25, the thickness of the styrofoam. Actually, they were downwards, okay? So I need 2 of those as well, all right? And those are, there they are drawn in, kinda, sorta, okay? If I can draw them in a little bit more here, I can fill them in, kinda, okay? So we've got that down there, we got this piece up here, kinda drawn in, right? So now we are left with just the last section here, and I'm going to need 2 of them, okay, because this is the front and the back, okay? So 1.25, and the way I get that 1.25 is that line right here, this red line right there I just drew, and that is 1.75 minus 0.5, okay, which is 1.25, because that 0.5, of course, is the thickness of the 2 sides of the styrofoam here, and then styrofoam down here, okay? So what's left in here now is 1.25. I think I wrote that there, okay? So 1.25, and that is actually going to be 2. That is still 2 feet, okay? That right here. And then, again, times 0.25, which is the thickness of the styrofoam, okay? So there we go. There's what I have. I have those 6 panels that will help cushion the material, all right? Okay, so the next problem here says find the volume of that cushioning material by adding the volumes of the right rectangular prisms in the previous question. Okay, so all of these right rectangular prisms that I created here, okay, these, zoom and zoom and zoom, okay, all of those, and there are 6 pieces total, I want to go ahead and figure out what the total volume is of all of those, okay? So let's go ahead and do those calculations, all right? So first I had 2 times 0.25 times 1.75 times 2 cubic feet. And then I had 2 of 0.25 times 2 cubic feet. And then 2 times 2 of 0.25 times 2 times 1.25 cubic feet, okay? All of those that equals 1.75 cubic feet, 2 cubic feet, and then 1.25 cubic feet for a total of 5 cubic feet. Yes, lots and lots of steps, but not impossible. Just have to be very, very careful and to account for what you need and to leave out what you don't need, paying attention to those 3-inch styrofoam pieces and how you're going to squeeze them in there, because the tendency is to make them too big, and not accounting for the styrofoam that's already been laid down. Okay? Alright, so now we're going to find the volume of the styrofoam cushioning material by computing the difference between the volume of the larger box and the volume of the smaller box. Okay? So, ideally, actually this is a second way of doing this here, ideally this 5 cubic feet will be the answer to this problem as well. So let's go ahead and do that. This is the volume of the larger box first. Okay? Let me pause here because I'm going a little bit too quickly here. Okay. All right. So the volume of the larger box right here, and those are taken from what we came up with, we calculated, and then the volume of the smaller box, which is actually given to us. Okay, that's the cubic feet. All right, we're going to do these calculations now. Let me come up with 8.75 minus 3.75 cubic feet, which is 5 cubic feet, which is the same as that, and that is a good thing. Okay, so two different ways to do this. One by actually using the pieces themselves here, or another way just using the difference between the two boxes. All right, and that's that. Okay, this took me a lot longer to annotate, to draw up, than it did to actually record. But hopefully you got enough, and I didn't go too quickly. Again, if I did, let me know, and I can help you out. All right, lesson summary. Okay, so to find the volume of a three-dimensional composite object, 2 or more distinct volumes must be added together if they are joined together, or subtracted from each other if one is a missing section of the other, which was the case with the triangles. Okay, there are 2 strategies to find the volume of a prism. Okay, you can find the area of the base and then multiply times the prism's height, which is that really quick way that we've loved so much, or I've loved at least, or to decompose the prism into 2 or more smaller prisms of the same height and add the volume of those smaller prisms. Okay, now there's nothing to say you can't actually use this strategy here when you're doing that, in fact. Okay. Yeah, decompose or look at it all as one. All right? Okay, well, hope you enjoyed that, and get those problem sets done. This is the second to last. Next lesson will be the last lesson in your grade 7 math year, and I am so excited to get that done, and I hope you are as excited too as well. Okay, good luck, and see you one more time.